Hello everybody, welcome to another stream. How are we doing? So last stream we got the top level BVH rendering, and basically this is a bunch of instances. It's not massive amounts, it's probably about 5 by 5 by 5 rotating tiles of ellipsoids. And each ellipsoid tile is I think an 8 by 8 by 8. So yeah, it's alright. Performance could be better, but yeah. So what I would like to do, what's interesting is it kind of looks like water, so it's like you know, with all those sort of reflections of the lights and stuff. It's interesting. Maybe we'll do something like this for water later on. Hey Retro Pixel, how's it going? Or Pixel, how are you? So yeah, this stream what I would like to do is record a devlog, just basically catching up on the work that we've done over the past, since the last devlog, right? The last devlog was talking about the bottom level BVH, but now we've got instances. It's not really good. We're not really going to talk about much to do with, to do with this. And then what I want to do is get onto this game tech plan, which is the work for the next 4 to 8 months. So we're coming off a rendering and moving over to banning this guy. Oh, what the crap is going on? Is it the new way they get around it? Gotcha. Yeah, so coming off of rendering and doing basically game technology. So yeah, I should probably talk about the kind of genre, this type of game I would like to build as well. But probably I won't go too much into the actual game itself because I don't want to like spill the beans too much on that. But just the general idea of what the game would be, genre and that, so people can understand what I'm building and why we've made these decisions. So the game tech plan, we'll be looking at this. It's basically every task down to the granularity of 1 to 3 streams, and obviously a sort of more of a macro task, which is like the overall thing we're building from a sub list of tasks. So I want to plan it out and go over the details after we've done the devlog, or just talked about this top level BVH thing, and go over my list so far and also improve it, do another take over it basically. And you guys can ask questions about it if you would like. Doing well, thanks for asking. How am I? I'm doing good. Yeah, just yesterday was my brother's birthday sort of meal, so we had like a hot pot, a Chinese hot pot. Have you had one of those where they sort of like have a bunch of food that you can quickly cook in front of you in these hot dishes that have got flavor in? So yeah, that was nice. And then when my family today, I had a roast after church. So just really been chilling this weekend. Oh, I also like completely took out all the plants in the front garden, and I pulled a muscle on my shoulder doing that. So that's been my weekend. I'm doing good. It's bloody warm, so I'm gonna open myself a Pepsi Max. Oh yeah. So let's recap on what Past Henry talked about in the public. So there is a YouTube channel. There's also a VOD channel as well, if you want to catch previous VODs. What did Past Henry do? BVH construction. I've got segments. So I talked about like what it takes to build, kind of like the, yeah, how to sort of build BVH on the GPU type of thing. Right. Neat. That's cool. So I'll just talk about how I'm using Intel or AMD CPU. Any Vulkan issues if using Intel? So I don't use any integrated graphics, but I've got an AMD CPU, and obviously that wouldn't have any problems running Vulkan. I've got an AMD GPU, like an actual GPU that's not integrated, and that's completely okay. Your integrated GPU shouldn't have problems running Vulkan. The Intel drivers are actually quite good. They're just not, the hardware's just not really that powerful. So you can't necessarily do too much on integrated stuff. Quite low resolution. You're probably looking at 720p at best for a game on integrated stuff even today. But yeah, it's really it. Right, so I think we should show the grid. We'll separate the grid, and we'll show we'll enable the debug drawing. So we'll not make them spin. We'll add a bit of separation, and what's my boy doing? I can hear him arguing while being fed. It's my boy. Yeah, waiting for Intel Arc and Battle image those GPU promises to be. What is Battle image? Oh. Yeah, I'm not sure what an XC core is, but that's probably a C, a compute unit. It's quite a good number. I think I forget how much mine has. It's pretty difficult with AMD because they have dual compute units, and so you don't know if you half the number or double it. You know, like when they give you numbers. But yeah, sweet. Right, SMs, they're their shader, whatever's. They're like compute units in AMD land. Right. Okay. So yeah, they'll do like a 4070 maybe, I don't know. Or in between 4070 and 4080. Yeah, hard to tell until we get running on it. But nice. More open source-ish GPUs doing well. We want more openness. We want more openness. Because really huge hype up from NVIDIA for their CUDA and ray tracing cores. Can you access the ray tracing cores in CUDA? I don't think you can. For crying out loud, my laptop. I shouldn't have updated it. You bastard. Oh, let me just hard reset this thing. Right, I'll be back with chat in a minute. I'll just restart my damn laptop because it can't update it. The lock screen. It will lock the screen after a minute, even though I set it to more than 5 minutes. And then when it locks, it's like, you tried to enter the password more than 5 times. No, I didn't. It just locked automatically, but earlier than I said it did. So I'm rebooting that now. I should update it again. Hopefully they fixed it. But yeah. So what I would like to do is disable the rotation. So look for the word rot. And we're gonna get rid of the rot for now. We'll add the rotation in a bit, but what I would like to do is also add a bit of separation to these. So if we add a bit of like, right, let's get the chat back up. So there's like some level of if we add some spacing. Oh, what is that about? Right, so there's that tile grid that was spinning. It should have minus. Oh, I don't even know anymore. Wait, they're kind of. Yeah, you wanna. How do you push it apart a bit? So that's taking half of it away. To center it. Yeah. Offset. Yx less than. Yeah, but just drop the scale down, that'll do it. To about 0.9. That should add a bit of separation so we could clearly see the tiles. Bit odd. Did I delete everything probably? Why is it so bizarre? It can be the I guess it's the quantizing of it, so it sort of looks like it snaps certain grids or something. Or we could just miss out the edge. Oh, it's instead of the tile. Yeah, let's drop the tile, the one at the edge. That'll do it. Yes, through a library though, CUDA versus open cycle will be CUDA may be right. CUDA is kind of an MPI for GPU with more CUDA core present. Right. What is going on here? I just changed this such that what will have made Right. Hmm. I'm going to zero these or something. Is that what I was missing? How are these? That'll make a tile. Oh, they're already overlapping, isn't it? Whoops. Right, let's drop even more. No. Right, screw it. I'm just going to show one instance instead, bring it down to one. One dimension. Yeah, one by one. So we'll talk about how we've basically all got instances now. Armadays I can't have one. What a shame. So that's 2 by 2 of tiles anyway. Yeah, so I need to also have a way of showing that debug shader where we do the ray tracing. So there's the ray tracer, and then in there's the, like, render the parent nodes. Yeah. So this one renders an outline. If you hit it. Top level leaf. That'd be interesting. Top level leaf. That's the one I want to render, isn't it? So when I press the escape key, you get the tree down. Oh no, it just does it anyway. Very lovely. We could do boxes. That's another way of doing it. It's so damn big as well. And I don't know what's happened to the normals now. Like, these used to be really nice colors. Right. Alright. So the closest hit depth gets set now. Right, it'll be missing like other values like the closest hit normal. So for those let's put that in quick. That was hits. Hopefully that's the right space. Nah, it's still messed. There's another one, wasn't it? Nah, I think they're in the wrong space. Doesn't matter. Not that fussed about it. Yeah, maybe we'll put a separation between it instead. Right, I changed my mind. So how will we do a separation? Well, if you get the vector from the center. Hey Sturdy Pose, how's it going? Yeah, I guess so. Guess it is. Guess it is. Maybe. So, if you got a 2 by 2, make them a little bit bigger than, yeah. Oh my man. See, they already overlap. Is that what it is? It's a bit bizarre. I changed. I'm definitely compiling this, right? Build, yep. In the right folder, not in the other one. So this is a unit of half dim of 1. Huh. If we make that 0.5, are they... Right. They still kind of look okay like that. So now if we add... so we're doing a 2x2 of the instances. Get rid of the instances. If we take the x and say... well, we could just... Or if we just say add 1 to x and y, does that at least put some gap between it? No, wait. Oh, 1 is way too much, isn't it? Because 1 puts it... No, it's in world space, so... Should be alright. No, we'll keep it the same. Multiply it by... Multiply the result by 2. That definitely puts a big gap in it. Right, easy. Yeah, he's getting tired. The boy's getting tired. There we go. So now we can talk about how we've got instances, right? So this is the tile 1. These are bottom level BVHs, and we can talk about how basically something like this. Yes. Amazing. Let me just check on them, make sure they're okay, and then I'll be back. Right, welcome back. Yeah, so he's just tired. He didn't want his food. And now he's having a little bath. Oh man. But yeah, I'll probably not record the devlog actually until he goes to bed, because if not we'll just get like screaming baby in the background. So yeah, well I think we'll save that one. So I'll just plan it out, then we'll get to that game tech plan and we'll discuss this. You guys can ask questions, then we'll get back to doing a recording of this. So basically I just want to talk about instances like that. How I've got them here, talk about the tree, how these will link to bottom level BVHs. I can then show the instances data structure, how they basically are just like kind of the same as ellipsoids. I can maybe show the API off where I've got this like BVH. Oh, I do have an allocator. See, this stuff I could show and I could talk all about it, but it would be a lot of work. But I do want to just provide a recap on. Yeah, I did also work with this sort of BVH API. Where we can give CPU side data for ellipsoids or instances, and sometimes GPU in this case. And then that will build a BVH on the GPU, and you get, allocate a block of memory for it. Yeah. All right. Yeah. So if we talk about the tree, at least we can talk about the instance data, and they're used to build a BVH the same as before. And then I guess we'll go over, we've made a custom heap allocator, basically. I'm not going to touch too much into it, but here's the API. It just gives you back a block of memory. See, it's a lot of detail just to brush over, this is it. And then describing this would just be like, we did discuss the BVH building in the previous devlog, so I could just say it fits in just the same as where the ellipsoids would go. And yeah, basically now we can have instances, and then maybe I can touch on the plan. Right. I've got an idea. So we won't really talk about this interface. I can show the data structure for the BVH build instance though. Yeah. And talk about how it's basically like the ellipsoid one. When you want to build a tree, just give it a bunch of instances, and they're your leaf nodes for the top level. Could I talk about the traversal code? It's not anything special, but I could talk about the algorithm that we currently use. Or currently do. It's got problems, that's for sure. Yeah, I think I'll just do those three things. Talk about what this top level thing BVH is, and then it will ray trace in, or go in and load the new bounded volume hierarchy, and then ray trace against those in the local space, the object. Talk about the data structures at least, and then maybe talk about how the traversal code works currently and what are the pitfalls. Yep. I think that would be a good bit of information. That's not just too much work to do. And then I guess I could talk about the tech plan in the devlog as well. Like, what is the future? So let's go over the tech plan now. Like, while we just wait for the kid to go to bed, he will go to bed in another whole hour, so we got time to do this. So the tech plan, let's open it up. Tech plan. So I wrote this out yesterday, Friday evening, yesterday. Friday evening I wrote one in Discord, in the Discord channel. I posted it. And then on Saturday I went over and refined it like crap. So I've ordered it in like a list that I want to yeah, this is the order. Is it better if I maybe view this in the web browser, or do we want to look like a hacker? That's probably a good poll. A. Yeah, I guess let's do something like this. Let's do a poll. Right. View Markdown. Browser or editor like a hacker. Right. Send that one off. Haven't watched you in a while. Still being the god of C programming. I wouldn't say that, but yeah, I'm still enjoying doing C programming and living a simple life. And yeah, I don't really get not really too many problems. I'm not really wrestling with the language per se. Wrestling more with maths and, you know, trying to figure out how I'm going to design this thing or what design I want to go with. So the general idea, right, if you haven't been watching, is we have finally, after over 100 streams, less than about 80 to 90 streams, we've been doing rendering, research, and development. So if you've done research and development before, what you realize is that you're just trying a whole bunch of different things, and those things take time to do, especially when you're doing rendering. So I did all sorts of different rendering techniques. I tried doing a bunch of spheres and tried doing BVHs. I'll come back to doing a BVH. And we're doing ellipsoids now. So we're building models out of ellipsoids. We've got PBR. We've currently got an implementation. It's not the best, but I will optimize it when we come back to rendering. I want to take a break because we've just been doing it for way too long. The engine has gamepad support, keypad support, Windows, Linux. It has custom memory allocation. It has a UI library, texture viewer, so we can debug like textures and things, take screenshots and compare pixels. It saves that to disk. It's got all sorts of goodness. Yeah, but what we still need. I had the list. Well, I don't go over the list so we are more up to date. But what I need is a way to build models, basically. Right. Let's have a nice chat with Alex here. Here was my stupid simple list. Now I've got a big old list, really refined. Oh yeah, and I talked about this. BVH PayPal. I was like, this is an optimization I would like to do in the future. But yeah, this is what I have done. We've got collections, a UI system, UI SDF renderer, operating system layer, keyboard, mouse, gamepad, a GPU layer over Vulkan, and we could do others. Logging system, a bunch of R&D we did. So rendering, PBR, parallel sort on GPU, texture viewer, screenshot tool, debug drawing. So that is a nutshell of what we've done. So now I want to move away from doing research and development, because research and development is costly. It just takes time, and you're just trying stuff and seeing if it works. Now I kind of want to have more of a plan, like we kind of had in the beginning. So I already have a game design, which I guess we can briefly touch over. Top down, kind of top down, RPG, tile based in a sense. Right, you'll be able to walk across tiles maybe freely, but it always locks to a tile. There's not going to be any custom physics or any 3D complicated physics, maybe basic physics. Very, very basic physics. Kind of turn-based, maybe not. Kind of an in-between of turn-based and real-time in a sense. Yeah, obviously turn-based, but not just very rigidly turn-based, if you will. What else? Yeah, RPG, probably procedural generation, proc gen. So right now, oh yeah, I'm not going to go too much into the game design and all the ins and outs of that, because I want to save that for the future, and also, but I got this other document, the game tech plan, which I just built, and this, the end objective is to have an editor where we can build models out of ellipsoids, because we're doing a custom rendering thing, which is very different from everything else. So we need a custom editor, but we don't want to go and spend ages making a complete custom thing that does all these things I don't want to do. So we just need to basically get a way to build some models. They'll be skinned, and we can have instances of them, and we could probably make a human out of a bunch of different parts and things like this. So it is going to have some level of complexity to it, but we're going to spec it all out and get down to a task by task level of detail in this to-do list. But obviously, in order to build an editor, I don't want to quickly build an editor that is going to be really messy code, and then, oh, I need to add threading support, oh, I need to add this, and then I got to rewrite a whole bunch of it. I want to kind of make sure that I do things in the right order, such that we can hopefully avoid doing many rewrites and refactoring. So sometimes it might just be put a stub interface out for the asset system or whatever, but don't actually go and implement the whole asset system, you know? To just really just get things in a place, and where they're just not going to cause us problems. Or if my UI library is missing things like a color picker, or the API is just not really that great in this certain area, fix it, and don't create a whole bunch of code which is horrible. So this is what we're planning out. Yeah, we're probably going to do a very simple cut down version of everything. R&D time was 100% worth it. Yeah, it was. Majestic Mac. And hello, welcome back. It was definitely worth it. It was a lot of fun and learning, actually. I learned a whole bunch of stuff. But yeah, I just wouldn't want to stay in R&D. I think I'm at the end of, like, I've had enough of it, if you will. It was fun, and I learned a whole lot, and where we got to, I'm happy with. But yeah, just no more. No more. Time has expired for that. Still have your hatred towards C++. Yeah, heavily dislike. I wouldn't say hate. You know, hating is not good. But yeah, heavily dislike. Glorious, welcome back, sir. How are you? Hello, got a bit of troubles with currency payment methods, so no more salutes from me for some time. That is cool, no worries, sir. I'm happy for you to be here regardless. I'll salute you, sir. Is we see how? Oh yeah, I got custom C compiler for GPU, so I can share C code and data structures between the CPU and GPU with limitations, no pointers, no pointers, and there's a whole, like, you can't use a boolean as well. It's another one. Yeah, returning variables from functions is a bit weird. You have to make a strut and return them out, but it's okay because everything's kind of inlined anyway. But yeah, it's called HCC. It's on GitHub. So I'll drop a link in there if you're interested in seeing some of the technology. Yeah, I don't really want to do HBlock anymore. Maybe I do. Yeah, I need to drop these in somewhere, this HBlock and the other one. I found for the BVH. But yeah, limitations. Oh yeah, we kind of got printing as well. We've got string support, which allows you to write out to a buffer, and then you can't have unions because you don't have pointers. No function pointers, obviously. Yeah, but it's good. It's pretty nice. I'm happy. Also compiles quick as well. I've got all my shaders. Oh yeah, it's another feature that it's got. You can have multiple shaders in a single file. It is revolutionary. So all the shaders just compile nice and quick. So happy with that. So with all the prelude out of the way and everyone's up to or caught up. So if you have any questions about what we just said, ask away. Happy to answer any questions. Also, if you have any questions about what we're going over, anytime, I'll answer those questions too. So big one, entity system. I'm just going to allocate 6 streams for that. I wish that it takes less. The basic idea is, based on the game that we're going to be making, do we need an ECS or not? We probably don't. There's also the question of do I leave it open? So the thing is, I think I'm going to have, it's a turn-based game, right? But I want to have the whole world simulated. The whole world simulated. And the whole world is probably going to have 73,000 entities, I reckon. So I don't think like entities that are going to move around, have some form of AI. So if the player moves, right, as they're doing the movement animation, you've got all those frames in which the CPU can just be busy running the whole simulation on the rest of the world. And even if you run all of the world which is around you, which is not visible, could just be catching up, right? But I guess if the player runs for ages forward, maybe you could catch up and get some problems. So I reckon 73,000 entities taking a turn should be able to be done. If it takes half a second to walk to the next tile, I reckon you can process 73,000 AIs in that time. And they can take their turns. So I think we might not need an ECS. This means, the word ECS is kind of overly. It's what I mean by ECS is do a data-oriented design for the entities. Have them in an SOA format where you can use SIMD and stuff to operate on multiple values at the same time. But I would like to spend one stream to at least think about it to see if I can do a very simple sort of design that doesn't ruin debuggability and doesn't get in the way of me programming a non-SIMD version, but also opens the door for a SIMD version in the future if for lower end hardware we do need a more optimized version. But I don't know until I've written it. So yeah, we probably would just go single entity structure. That's the easiest route. So yeah, we've got one stream which we're going to start on Tuesday where we'll really dig into the entities and talk about ECS systems. And also, when I talk about ECS, I'm not talking about, the S part I kind of dislike. You're building multiple threaded job system into the entity system. I think you should just have a job system outside of entities, and then so really I'm just talking about just having arrays of components, really, or whatever. But yeah, that is going to be happening Tuesday. We'll start off with this because realistically everything else depends on having entities. So we're going to allocate 6 streams for that. Bear in mind we're going to times all these numbers by 2. So this is where I've got the 4 to 6 months time scale from. So I don't think there's too much to go in here. So we should spend about 2 weeks on that. That's 6 streams. We stream 3 times a week. The graphics public API. We wanted to be able to produce render data from game logic or entities. So after going to entities, we literally just have a few models in the scene described in the game. We need to have a game. We probably should have like a logic folder or something, or simulation, whatever you want to call it. And that's where all the game logic goes. And then that will make render data to this graphics thing that we're working on. It needs a way for us to feed it. Yeah, it needs a way. Maybe I shouldn't do that here because that's part of the after we've done the job system. Yeah, maybe we'll think about moving that. So building a DAG to figure out what entities to process in parallel is out of scope for this project. Yes, probably. We'll see. Like, we shall see. Like, if you take a look at ECS stuff, people build very complicated libraries, and then they've got like really key flaws in them, and people are like, oh, these things are fast, you can handle hundreds of thousands and millions of entities. But then, like, if you look into how they're implemented, they're actually kind of terrible, and they're not really good for data orientated anyway. ECS is only valuable when we want to touch memory that we will use this instance. Approach, not in organizational sense. I would definitely try hardcoded struts approach, but you eventually will touch memory that you don't need yet. Better than God entity approach, though, I think. Yeah, so yeah, we might only have like a few hard-coded entities, but the key thing about ECS is that it allows you to kind of it depends on the approach. If you take the archetype approach, or the sort of one global pool of entities and components. But yeah, if you have that more global pool approach, you've got this ability of like adding a new component and taking one away really cheaply. But then the problem is you get tons of holes in your arrays. So when you try and process it as SOA, it's like, well, I don't know how many. Like if you go over all of your components and they're kind of like not half the entities have them, you have a lot of holes. Where if you have like archetypes, which is basically like kind of dynamic data structure pools, you'll have less holes because all of those components are basically required by that archetype. So the only holes you have is the deallocated pool slots. So yeah, it's also when you have what was your question? Yeah, the picking up memory. Yeah, and also with ECS as well, it assumes that your algorithm is traversing the whole, traversing over all of the entities with this component, or whatever, or all the archetypes. But if you want to do an algorithm where it's like a scene graph or something, where it's like references, then the ECS model really falls apart there. Yeah. Yeah, we're probably not going to do ECS, but I would entertain the idea of at least having some SOA type of organization. Yeah. But entity could change its archetype, and default approach for this is to postpone archetype changes to the end of the frame and do them in chunks manner. Yeah. See, that's the thing anyway. You want to be able to add, so in a for loop of like going over all the components, you want to be able to add or remove an entity. But when you do that, you could be adding or removing entities which are in that for loop. And then that just creates a whole load of problems. So you kind of want to actually defer a whole ton of different results to the end of the frame for those reasons too. I haven't ever tried ECS. My assumption is that currently that the lion's share CPU time is things like skeletal evaluation and actual spatial testing, ray tracing, scenery. Every project is different, of course. Right. Yeah, that's the thing, right? You don't put like you don't have that like hundreds of thousands of entities in a game usually, or like all simulating. It's an optimization to not do that. And whenever you have tons of things like particles or whatever, you put that in a different system, right? You don't put it in the ECS system. It's just a dumb idea. But yeah. Oh yeah. See, that's another thing as well. Is all the main ECS libraries, they've got real key flaws of how they're designed, and then people use them or they're touted as like, oh, this, you know, they are oriented thing, but they're really just bananas in their design. Yeah. Um. Right. Right. I'm actually going to remove ECS. It's a very polluted word. Data oriented design. Oh, there we go. Clearer. Yeah, so basically we want to add OS threading support, right? So unfortunately on Linux we've got to use pthreads because if you don't use pthreads, I think it's difficult to set up the thread local pointer. Yeah, I've never figured out how to do it. There's probably a way to set the register or something and allocate the TLS thing, but never done it before, so we'll just use pthreads, and then on Windows we'll use the whatever the native threads thing is. We're not using C threads or C++ threads or whatever. We'll just use the operating system ones because this is the way. So I'll take a stream. Job system, we want to make sure that we've written basically one game system already, which is the graphics, and we've written some engine systems like UI, OS layer, GPU layer, and a core layer for like memory allocation and dynamic arrays. So we're going to be adding an editor and a game logic thing. So we really should get the multi-threaded stuff out of the way. So I've not really done it before, but I want to do like a job system where we have dependencies and everything is a job and run it that way. Because I've been doing tons of GPU programming and I basically have convinced myself that we should design a job system where it's like a shader. Where every job is like a shader, you can have, you can launch a job and launch many instances of that job. So like a compute shader. So I want to do something like that. It'll be bonkers, it'll be crazy, but I think it'll be fun, and it could open the gate for multi-threading those entities, which could or could not be in that data-oriented design, right? If we do go the data-oriented design, it'll fit real nicely into that sort of compute shader kind of design, because you'll be like, oh, I'm going to launch, this many groups of this job, and that would then be divided by the number of like SIMD, the size of your SIMD lanes or whatever. I don't know. Maybe we won't do that because that sounds more complicated, but we might leave the door open for it in the future at least. Yeah, sorry, we're not going to do that stuff right away, just so you know. We're designing this so we'll leave the door open in the future to do it. We're not going to do SIMD right away, but it's just going to be there so the door's open. And minimal refactor, basically writing another implementation of a function. Cool. Because we're doing job systems, we need to make sure we catch when we mutate multiple objects across different jobs. When we mutate the same object across different jobs. So we have a dependency system. I want to try a dependency system rather than doing like barriers and stuff, right? Because I think that's very error prone, and I want to see if we can get away with a dependency system that's not got a lot of overhead. And basically this is all kind of inspired. It's not the same in any way, but the Destiny multi-threaded stuff at GDC talk by this chap, and there's a rendering one as well. Crying out loud, I clicked on that, didn't I? Google USOB. Right, yeah, YouTube, man. What you're supposed to do. So this is where it's kind of inspired from. Oh yeah, that Fibers thing. Yeah, they took the industry name Fibers, yeah. Yeah, not Fibers as in the green threads. There's a different thing. It's kind of like inspired by I like the idea where they can run it in like a debug mode and catch they can verify that it is thread safe, right? So I want to try and do my own version of that, where we basically, every pool of entities or whatever will have another sort of resource job tracking system. So it will be slow in debug builds, but it'll catch the problems. Or maybe we have a special build that runs that does this, but we don't run it all the time. So when there's a problem, we'll jump into this one and then we'll hopefully catch the problem. So this one shouldn't be too bad. It's literally just an array of jobs and some algorithm to sort of like be like, oh, this job's running potentially at the same time as this job, and they both mutate this entity, and then log some really good information and be like, problem. So that'd be really sweet. I'm really excited to do that. Right, let's catch up with some chat. But yeah, any questions, guys, feel free to ask away with any of this stuff. Some people say you can even do skeleton evaluation on GPU. Yeah, I think you do that these days. Yeah, you do GPU skinning. GPU skinning all the way. I've heard it said that ECS is a really good solution, how it separates engine and plugin user code. If you have 100% control of your code base, then it's not needed. Yeah. So that's another reason why people do it, is because you've got that OOP approach where you have the base entity. But yeah, if if you want to have the engine provide some level of entity support and pre-do some things, then I guess ECS has a way of doing that, and then they can extend it, or the game can extend it. But or the other approach is you don't provide any entity solution, and you just let the game call an API, like the rendering API, and it has its entity stuff that it transforms into the render data or something. So yeah, it's a way of providing an out-of-the-box experience of entities, which, yeah. What else? At this point, ECS has so many meanings you can't really say that. I mean, ECS is used for the first Thief game in like '97. Yeah, I remember seeing John. Oh, John, not John. I've read the id Tech thing. My brain was like John. Sean Barrett talk about that, I think, sometime. The id Tech 7 approach, I like it. Cool. It depends for audio. Audio programming, same with network programming, is something I really would like to do and try. I've just not really. I've done a bit of networking actually. If you've followed me long enough, we did it on stream. So we are going to be doing definitely networking at some point. Before we do the game systems, I think we will put a networking thing in. Audio, I have no idea about audio, but when we have a basic world in, I'm sure it'd be a good idea to get some audio in, at least an audio system in, for sure. I've just never done it. Do you have a link for the Destiny rendering talk? Yes. So that one is behind the wall. It's on the GDC side, but it's actually unlisted on YouTube. So if you search for it in Google, it will come up. Destiny multi-threaded rendering. So the TLDR is basically takes that. Yeah, see, here it is. Oh no, damn it. There's a link to it. You can get a link to it. I've done it before, or it's in like a playlist. Yeah, by Natasha. I think she worked at uni for some time after, and she runs that one of those conferences. I forgot what it is now. Advances in real time rendering. She runs that, or she's part of the people who do that. GDC. Am I? Well, anyway, it's on. Oh my boy, he's going to bed. It's on the GDC website. Oh, I probably had the link in it. Yeah, it happened 2015. Oh. Is that right? Has this got it? Oh, it's the PDF. There was a video there. But yeah, the key takeaway is they basically like produce that render data on the game thread, and then they'll like pass that to the GPU thread, and then they talk about all their different. Oh yeah, they jobify everything, isn't it? Yeah, maybe this is alright to follow. It's got the speaker notes. Yeah, it's a good link. But there is a video on it if you search on the Vault, 2015, same year as this one, and there is an unlisted video on YouTube, but it's difficult to find. I had it before. Oh well. Right, any other questions? Guys, try Bevy? No, don't do Rust. Why does CPU eval of the joint matrices, right? I still want them CPU side for collision and plucking the right. That kind of makes sense. With the skinned vertices, of course. Ah, right. Right. I see. So you can do like the right, like a lower resolution skinning on the CPU for things. GCTO of Activision now. Wow. That's cool. I didn't know that. That's impressive. He's had quite a good career, I think. Yeah. A lot of stuff. In quite a lot of good places. Cranston, good to see you, my friend. Right, so yeah, that would be super sweet if we could have some way of like running a system, catching data races, or the majority of them, right, at runtime in debug builds. That would be amazing. Then we jobify the game. There's basically no game. Not gonna be too long. So yeah, this one, oh yeah, it'll be 3 streams. Jobify the game, 2 streams. So we'll have like a bit of game logic. We're basically just running that, produce the render data. So I'm thinking this graphics public API, maybe we boost this up to 3 streams, get rid of this one. So we won't be able to see the entities on with graphics after this, but we can at least just print them out or whatever. You know what I mean? And that'll be good enough. I'll be happy with that. And then after we jobify it, we'll produce all the render data. And yeah. Cool. After that, we probably want some form of decoding slash encoding system, serialization. What have I done in the past? I've done type table based systems where I've generated type information. It is quite a reasonable approach. You basically could get type information for a whole structure or manually write it out and maintain it alongside your other thing. So you could then simply just write a serializer using this type information to go over this type information. Save that to disk, load it back in, voila. The downsides to that approach is that 1, you lose control, and 2, debugging becomes a pain because you're debugging, when you're debugging serializing an object, you have to go into the serializer code, which goes over type information, and it's a lot more painful than just going over handwritten functions, which simply say, write this field, write that field. So, like all good programmers, we go to and from solutions. Like this is the first one you write out typically when you're a junior. Then when you become more of a mid-programmer, you're like, oh yeah, automate it with a system. And then when you've done that one, you're like, oh, I'm going to go back to the handwritten one, like I did when I was a junior. So why are we going to do that? There is 2... Yeah, so question is, why do we need the system? Obviously, we're building an editor. We need to save and load stuff. Right, there's the why. We basically want a text format for source control, and then probably a binary format for when the game is shipped for speed and things like that, and more efficiency and stuff. So because we're only really going to have 2 types of serializers, we won't have lots of... Yeah, so we might combine the encode and decode stage into a single function. so that when you write out the manual function for your data type, you only write one function for each encoder, if you will. And it just has an if statement to say, are we encoding or are we decoding? And it'll either write to the pointer or read from the pointer, or read from the file or write to the file, that sort of thing. But we might also write an interface. Did I write that here or have I removed it? No, I removed it. So, or maybe I didn't write it in the first place. Yeah, we're probably just going to write, so for each type we'll have a text encoder and a binary encoder with a different API, but we'll have full control. So we'll be able to say like, well, write out in this, quantize the value and write out these bits and read them back. You know what I mean? So that could be useful for the networking thing as well, is to have a way to encode into some binary array and then decode it, right? So yeah, 3 streams on that, maybe that's a bit. So writing a text encoder and a binary encoder in 2 streams with 1 stream of redundancy, or of yeah, just in case, yeah, maybe it'll take 4 streams, we'll see. That should be right. CPU side joints plus bounding shapes, boxes, capsules, whatever. GPU side, every mesh vertex. Yep. Yeah, that makes sense. That's cool. Right. So, asset system. Why do I want to write an asset system? Because I could just read from files or whatever, but the problem is that it will be scattered across the code base, and then we won't be able to find like, oh, this is actually reading an asset type of thing. So but you notice I only got 1 stream allocated for it, because I just want to write a basic API which literally just like reads a file from the asset folder, and then in future we can come and maybe do a virtual file system or maybe do a build system thing, right? That's for future me to figure out. But for now, I just want to basically write a wrapper API so it allows me to quickly find like, oh, this is where I do the asset loading. So we can change the code there and deal with any future problems rather than having random file reads and stuff. So yeah, that'd be 1 stream. Prefabs and levels. Probably spend 3 streams on that I've got. Let's verify what we're doing. Prefabs and levels are for testing and modding purposes only. Since this game is going to be procedural, like proc gen, but we want to have some test levels to sort of like test that behavior of a set of entities and then maybe run them, or just have an empty level and just drag some stuff in and test things out. So they just need to be able to store basically entities and whatever yeah, I'm not sure if we we can extend it to do like logic things maybe, but I don't know if we will have that type of thing. I think the logic is all going to be driven by the game systems. No specific logic in the prefab data, I think. So it's just little levels and prefabs. So that's just basically run a format and loading and saving code. So then at this point we'll have a world. Be able to have a world and load and save little little levels and stuff. The next thing we do, because we're building editors, right, is to be able to hover over one of these ellipsoids or a model or whatever, right? Here they are. And be able to be like, am I hovering over this thing? Well, we're ray tracing when we're rendering. So why don't we just get, when we hit an object, we can know exactly which one we've hit and get the exact ellipsoid and the exact normal. And maybe, yes, when we click, we'll be able to know what model we've hit. So that'd be useful for the editor. Rather than having a CPU side version, we can just read back some data from the GPU. Gizmos. We've got a 3D drawing API. You guys have probably seen it, and a 2D one as well. We need to add any missing shapes. I don't think there are any. But we need a translate tool, rotate tool, and a scale tool. So translate tool is just 3 vectors. We've already got support for that. Rotate tool, we could probably use the we might have to do some custom rendering there, but we have got that ellipsoid border one. So if we use the ellipsoid border, that is basically a rotate tool, I reckon. And then a scale tool, I guess we can just use some boxes for that or something. Yeah. So that'll be, obviously, building an editor, so you need to be able to drag and manipulate data, right? So we need gizmos. Is there a specific reason why you want to support modding? So I haven't really thought about modding to the degree of like people making to the degree I've thought about it is people making people being able to use the editor tools to make different characters, different and different different items, if you will, to make a entity look different. I've not thought about how, because the thing is, the game would be like this procedural generation thing, this world that gets generated, right? So it would be cool if people could make their own sort of like items or changes to that could just go into the system that already works. The thing that I haven't thought about is like, I don't know how I want to provide modding support for people to change the logic of the procedural generation stuff itself. I would save that for when I actually write that code, but I think it would just be nice, because the thing is, the game's going to probably ship with the source code. But I don't think this game will play nicely with people getting patches of different patches, and so I think the source code would be a way for people to sort of learn and tinker with a game which has a specialized code base for the game. But I think the modding support would be a good idea for end users to have a bunch of little additions to the game that I couldn't provide or they think are cool. Right? I like the idea for that to be there at least. Whether or not, yeah, because yeah, I think it's a good community thing, modding support. It helps the hardcore fan base do their own little things. Yeah. Have you thought about adding that to your game, Glorious, sir? Or are you going to completely skip it altogether, or what are your thoughts on modding? I've allocated 3 streams for UI maintenance. So we're going to be writing a bunch of UI code. I don't want to just make a bunch of UI code that's going to get refactored. So if there's any sort of like things which need addressing to make, so I don't just create a bunch of mess, basically, we'll do that here. Then I've allocated 3 more streams to do a nice widget to pick some color, pick a color. That'd be a bit fun. I've not done that before, actually. Non-programmer modding can be a bit of work. Yeah. Yeah, well, I'm already building the editor tools anyway. So, if it's just basically adding to a list or having another list of things that get loaded in, I don't think it will be too bad. But yeah, I'd have to make like a way to, like a mod loading system and all these things, right? I will not support modding. I thought to give the source code with the game or open up a bit later, because I don't want to build specific stuff for it. Right, that's fair enough. Yeah, I just think it'll be very... Yeah. I'm not sure about the code idea of like giving people a way to script things, because like if you give them like a C API, they could crash the game. But then if not, the other system is like bringing scripting support, which is like you know, it's right, code that interops, make an API, pick a language out of all the languages, and then like make sure it works, and then handle all the edge cases where the scripts fail. How much time will it take you to finish this? Are you talking about this document? We haven't added it up yet, but I think it's about 4 to 8 months of work. This is the game tech side of things. With the end goal of building an editor to make custom models in the game. But yeah, we're planning for... Yeah, so 3 streams for like maintenance, 3 streams for the color picker stuff. So the first editor I want to build, the quickest, easiest one, is just a material editor. So material as in like metalness, roughness, and what else we got? Albedo. What else do we have in our material? Emissive. We've already got emissive plugged in, to be honest. Well, we haven't got like bloom or anything. We just got, it just adds the color. So it's very, very poor. So yeah, we just had a way to just basically mutate these values and see some ellipsoids, or one ellipsoid that you can sort of pan around and sort of scale it, and maybe stretch it, you know, change the dimensions of the ellipsoid. That's a good point. Change dims of ellipsoid. So yeah, the materials properties, no texturing support yet, no painting support. There's probably something I want to add in the future, you know, that would be pretty cool when we do more rendering stuff, but we just need something basic where we can at least have different colored ellipsoids and different basic material properties. Yeah, I don't know yet about these 2 things, and they're way more work, so we're just not doing them. So this one is basically, yeah, one ellipsoid in the middle, got a panel on the right hand side with properties. We can change the properties with sliders and text fields or whatever, and then we have a way to make materials with a name, save, load. Oh, I didn't write that. We need to have a save load support as well, so we need to have the data format. So that's very basic, right? We're just saving out a bunch of floats and done. So I'm hoping 3 streams for that. Again, we're timing stuff by 2, so it should be a week of working on that and done. So the next set of things is where it starts to get complicated. So this is where we might do some drawing to describe it. So basically, we want to always make some models. You know, save and load that to this. That's one stream. I'll just allocate for that. So we're going to editor 1. So for the editor format, I want to have a list of edits. So when someone opens up a model, they can just see, oh, how was this model built? And or be like, oh, I've made some changes, but I like I made some changes in my previous session and I want to undo them. They can just undo it here without going through the version control system or but then the game, when you save it for the game, is actually just going to be a final set of ellipsoids. So there's 2 different file formats there. Undo and redo system. You know, you basically want to be able to add and remove ellipsoids and set a material for them that is made in the material editor. That might take 2 streams actually. Let's move that set material out to a whole stream, because you probably want like a UI to be able to, you know, quickly search and then apply it, and probably preview it, maybe, right? So actually selecting multiple ellipsoids and stuff will be one stream, just to, you know, that's just a allocation thing, time allocation thing. Maybe we could, it's probably going to blend into another stream with something else. Render a selection outline. So I have selected multiple things, get selection outline in the rendering code. That'd be a bit fun. I've not done that before. Camera controls, so we need to be able to like move around. We also need to be able to snap to planes, such that you can get the viewing angles that you want. We need to be able to transform a single and multiple selection of things. So translate, rotate, scale. That could be quite complicated. That could be a bit fiddly, shall we say. So I've allocated 4 streams for that. We need to be able to, right, we'll save that one for later. Yeah, there's also this bone system as well. Now, this probably should be done later, but I was just planning out everything that I wanted to do. So what I might do is break this into phases. So this would just be the initial one. This is just the initial model editor, and then we'll probably have like this model editor with animation. So this one would come so I think should I bring the prefab editor up, I think. So I guess we can iron this one out now. So yeah, so prefabs, or like a level editor, basically. So the way that I'm envisioning it, right, is if you press the F1 key, you'll be like playing the game. If you press the F2 key, you'll jump into like the prefab editor or something like this. Press the F3 key, you'll go into like the model editor, and the F4 key, you'll be in like the material editor or something. So you can jump between these different editors, they'll be live. And each editor will have a bunch of tabs. And so you have different things open. So while I'm developing the game, I can always just jump between these different editors and change things to do with the models or whatever, and then jump back to the game and just see it all running. So the prefab editor will be especially if you like proc gen the world. So hang on a minute, I really want to look into some of this stuff. Obviously it was used to build test levels, but you'll also be able to use it to be like, hang on a minute, what are the properties of this thing? And just jump in there and see it in a paused state and just analyze it, and maybe like, well, if I move this guy over here, what problems are there or whatever, I don't know. Or if I change this value now, what are the problems that arise? If I make this guy angry or whatever, I don't know. Whatever the things are. So it'd be really useful for that. So I've not really scoped this one out. That's the problem. Right. So it's let's just put an overall time here. 1, 2, 3, 4, 5, 6, 9, 13. Right, this one needs to be moved as part of the animation. No, it isn't. So that's 13 streams. Overall. So that is what? That is a month's worth of work, basically. That's time allocated, a month's worth of work. But I'm going to double it and say 2 months. But hopefully it's less than that. I'm hoping it will be less than that. So I've over allocated in some regards, I reckon. But we'll see. Because there's always those little things that pop up where you're like, oh, that took longer than I expected. So I've over allocated on the ones that I would know would be kind of simple. So prefab editor, we want to be able to create so we'll have like, we want to have a way to see. I think the tile map thing is going to be different. Yeah, because I don't think the tile map is going to be like an entity. It's going to be its own system, because it doesn't make sense being an entity, I think. So we should probably put that into, so let's run something visual for a minute. So if you imagine if you got like tiles or whatever, so that's something else that you build in that model editor. You build your tile. It would be a certain size, whatever. So you can imagine there'll be like kind of like a voxel, like in Minecraft, right? So you imagine you'll be able to like paint some down. You'll be able to like paint them down, and maybe you'll be able to delete them, and the entities sit on the most top voxel. I don't think, since it's sort of like a top-down type of game, I don't think we're going to have gaps on the I don't think we're going to have gaps, and I'm not sure how much. Like, I want to have the game to probably be able to destroy tiles, right? Which means you're probably going to have support gaps. Yeah, so I guess for now, we'll just add support for like putting down voxels by just sort of like selecting, or sorry, tiles, sort of just dragging over and placing them on top of other ones. The thing is, though, you should probably start a level where if you start a world or a level or whatever, you could probably give it like a world size. Yeah, that's it. So, ooh. And then that will create a bunch, just literally like a 3D volume of tiles, and then you can edit it from there, I guess. Am I going to do my own physics? Yes. So there's basically going to be no physics, like physics simulation. There's probably going to be basic things like moving the player. Maybe there'll be some form. There'll be like a grid collision, and there's not really going to be like we might do stuff with I want to try and cut down on the amount of time that we're going to spend on things. So physics might be the things where I cut because I don't think it's needed. It's kind of like a turn-based game, so I'm not sure if it's going to be any benefit really. But there could be something where I'm like, well, if we put an explosion in, it would be cool to have something physical. But maybe that's render side only. But maybe it's actually in the game, and it makes the environment react, right? Because it's all physical. So I might do that, but I'm not sure. But yeah, if I did that, I might write something. I'm not sure. I quite like writing my own stuff, so maybe. So yeah, it'll be probably, but maybe there's something that I could use. I'm not sure. But for now, the idea is basically no physics, because I don't think we'll need it. But maybe. So you need a way in the prefab editor to say file new level, get a grid of, generate new level. Generate new level. Basic grid, 3D grid of a tile. Maybe it's like like a ground tile, of a ground tile. Just so there's something there, right? And you're not just placing it on the most ground level. Yeah, so I guess that would just be like one stream, say, of allocation. So when you sort of edit those tiles, see, should the tiles be part of the entity system in some way, or should there just be a 3D grid which just points to an entity that's occupying it? And maybe points to a tile. Yeah, maybe they are part of that, like a general system. Um, but yeah, so we want to have a way to sort of like place down tiles, if you will. So yeah, paint, paint or like add remove tiles. So allocate that one stream for that. That'd be like painting down. So when you do the ray tracing against the scene, you would get an object. So you would generate a level of a certain size. You probably can't get rid of the base tile. So you have like a kind of like a Minecraft bedrock thing where you have like a with one layer of bedrock, if you will. Let's just call it bedrock. Cannot be removed. So we can always ray trace, hit that bedrock tile, and get feedback from the GPU, and then we can know like, oh, we've hit that tile and we want to put something on top of it or remove that one, right? So that should already be part of the feedback system. So that'd be pretty neat. Add remove tiles. We obviously want some form of undo redo system. Maybe that's already, let's just allocate one stream for that. But it will kind of be probably interlaced. Is that everything to do with tiles? You want to be able to probably group select. So will it be painful just sort of like painting stuff down like that? Or when you're painting down your sort of like tiles, you could probably say, hey, keep it to this level, or do what Minecraft does in a sense, where it stays to the level at that you're placing the block on, I think. Well, that was like a first-person camera, isn't it, moving around? But you could probably keep to the level that you're on. When you click and when you release, you can go to other levels. Or other, not levels, but yeah. I think I'll save that for later. So deleting could probably be a similar thing. Yeah, maybe we'll think about some more things, but it should be good enough. So then you need a way to be able to create different entities basically, and place them down and configure properties. So yeah, tiles won't really have properties maybe. When you make a model, maybe there'll be some properties that we need to add somewhere to a tile. That could probably be done in the model editor. Maybe there's some kind of physical property, like this thing is made of, this thing's like a natural earthy thing, or this thing's a like a leaf, like a plant, and maybe that can interact with something chemically, like the Legend of Zelda thing. So those, if I have those systems, those could probably be put in the model editor or something. So they'll be on a tile. But in terms of like creating entities like organisms or something, those things need to be able to be brought in. At this point, I won't really have any. I would have been able to make models. So maybe we can have another type of model called an organism or something. So we want to be able to have a tile and organism model type. You can kind of select when you're building it, so they'll be put into these different categories of things. Yeah, so we'll just say create a sort of organism from a list of models or whatever, right? So you want to be able to transform objects? Do you mean just like you probably don't need any form of, you might need, the rotation is probably like, yeah, locked to 90 degrees maybe. In these cases, I don't know. Scaling maybe. Yeah, I'm not sure about that. We can think about it when we do it. So let's allocate a stream for that. Let's allocate a stream for transforming. I don't think we want to do anything as complicated for as complicated as the model editor, where it's got this sort of like you're building a model where you can rotate these ellipsoids. I think they're mainly going to be locked to a grid, or 90 degrees. Right, so that's the hope. We'll see. Edit objects, object properties. So I guess we could put maybe a couple of streams down for that. Yeah. Right, so all in all, we've allocated 7 streams for that. So that's a couple of weeks, basically. So we'll be able to mock up some levels or whatever and put things down. Save them, load them. We didn't do that save load system. Right, 8 streams. A week and a half. Right. So I think I got to the point now where my son has gone to sleep. So I think there's going to be a baby crying in the background. So we've gone over this. Have you guys got any questions so far you want to ask me? We're going to record a quick devlog about the top level BVH stuff. Maybe recap some of this stuff for the devlog as well. And then we'll get into the sort of like more advanced end of this editor. So that would build the model editor, prefab editor, then we've got some animation system, some organism thing where you can make some organism, and I probably want to talk about that and refine some of that. So just quickly before we get onto the devlog stuff, let's add the times up and see where we're at. 6 plus 1 plus 3 plus 3 plus 3 plus 3 plus 1 plus 3 plus 1 plus 3 plus 3. Wait a minute, what did I do now? 1. Yep. Model editor next. Material editor, sorry. 13 for the model editor. 8 streams for the prefab editor. So that is 54 streams. So I do 3 streams a week. Just 18 weeks. So divided by 4 for months, 4.5 months. So that's just to get a basic version of those editors in, and obviously some other game technology stuff that we mentioned before, multi-threading and things. So the more advanced stuff will come after, and that's additional stuff on top. So if we times that by 2, that's about 9 months of allocation. That's about 9 months if we do very bad in these estimates and times it by 2. But I've hopefully over-allocated a bit for those cases already. Right. So let's get to recording a devlog. All right, things all okay. I didn't realize I'm kind of like this. Oh. I didn't even do anything. Classic OBS. Right, devlog. There's a button here. Right. Hello everyone, welcome to another devlog. So today we're going to go over the top level BVH building, and Hello everyone, welcome to another devlog. So over the past few weeks I've been getting instances of models rendering by having a top level bounding volume hierarchy that then links to the bottom level bounding volume hierarchy, and also just been not time. Hello everyone, welcome to another devlog. So the past few weeks I've been basically working on a top level bounding volume hierarchy which allows us to have instances of these meshes on models, right, of ellipsoids. So we'll get into this, and then after we've gone over this bounding volume hierarchy thing, we'll go over right, there's a better way of saying this, but that's basically it. Take 7,000. Hello everybody, welcome to another devlog. So we're just going to recap on what we've been doing in the past 3 weeks worth of streams. We've been working on this top level bounding volume hierarchy, which allows us to have instances of these meshes or ellipsoid 3D models. And then after that, I would like to give a quick overview of the plan that I have for the next 4 to 8 months, which will allow us to basically build these custom ellipsoid models in the game and other things as well to do with the game technology. So let's get into it. Boom, that's pretty good. Yeah, so we're going to talk about these... Right, so if you remember from the last video, we basically build a tree on the GPU where each leaf node of the tree is an ellipsoid. So imagine here this is an ellipsoid, that's an ellipsoid, that's an ellipsoid, and that's an ellipsoid, because they're the leaf nodes. And the parent root node is, it is a bounding box around all of the child ellipsoids. So to add instances support, rather than, so the basic way of adding, okay, this one again, it could be smoother. So if you remember from the last devlog, we were talking about the bottom level BVH, where each leaf node is an ellipsoid, how you basically add instances to a ray traced bounding volume hierarchy is you essentially have a top level bounding volume hierarchy where instead of each of these leaf nodes, where these are all leaf nodes here, being ellipsoids, they're instead an instance. So we get more into what an instance is in a second, but essentially basically when you ray trace and hit this node, you will then link to a bottom level bounding volume hierarchy, and you will then ray trace into that. It'll be a whole other BVH tree. So the tree might look like something like this, where it's a bit more deeper, and you'll traverse through this tree, and then when you're finished, you'll come back up and then go back to your top level and test against the other objects and go down maybe. So this is how you add support for instances. So as you see here, we've got 4 tiles essentially, where each tile is like an 8x8 set of ellipsoids, and the tree for the top level would look something like this, where we would go over each of these and ray trace against these. But obviously there's no improvement to not having this BVH because there's only 4 nodes, but as things progress, we'll be able to save down the amount of computation by skipping, traversing down all the nodes. Right. I think I talked a bit too long there. Kind of waffled. Let's do one more take. Bit of waffling. Right, so if you remember from the last devlog, we basically had a single object, which is a bottom level BVH made of ellipsoids, and each leaf node was an ellipsoid, and as you went up the tree, those parent nodes wrapped a bounding volume around those leaf nodes and so on. So you had a whole tree of this, what's known as a bounding volume hierarchy, so we could accelerate the ray tracing. So this is a bounding volume hierarchy where it's just got 4 leaf nodes, but instead of each leaf node being an ellipsoid, it is instead an instance of a bottom level bounding volume hierarchy. So when we ray trace against these leaf nodes and we hit one, instead of rendering an ellipsoid, instead we swap out to the bounding volume hierarchy for that instance, and then we ray trace down this bounding volume hierarchy until we hit all the leaf nodes that we're going to hit, and then we traverse back up to our top level BVH and carry on there. Okay, that's good. Right, so I think I'll change the code and show off the bit more of a complicated scene. Hey, where's my rotation at? Let's wait for the kids to go past that side. I really like this. It looks like water. Maybe we could do water like this in the game, where it's just a bunch of like rotated instances. It's probably not the best for performance, but it could look pretty cool. Or maybe it's just a single instance where we animate it or something. Maybe we do some sort of up and downs as well, like wave looking things. Right. So here is a 5x5 grid of those 8x8 gridded ellipsoids, and they're rotating around clockwise, and they're producing this really nice looking effect, especially with that PBR where it looks like, kind of looks like water in a sense. So yeah, this is just another type of tree, something like this. This is not the actual tree. I'm just showing another example where each of these leaf nodes represents a 8x8 grid of ellipsoids, which is an instance, and each instance has like a transform which puts it into the world space and, you know, does rotations and stuff, and when you hit it, you'll then open up into a whole other BVH and traverse down those as well. So down here, you'll see the performance is idling around 6 milliseconds. So we could definitely improve the performance. You know, as we get closer, it gets worse. As time goes on, we could definitely improve the performance. Yeah. I take that one again. I think there's probably a bunch of background noise as well. But I have a take. Right, the background noise seems to have been gone. Let's try again. Right, so here's a bunch of instances being rotated around in world space and rendered using the BVH ray tracer. You'll notice that it kind of looks like water and it kind of looks quite nice. Maybe we'll use something like this in the game. But yeah, so, you know, the tree would look something like this. It's not actually like this. This is just an example of how a tree would look. Where each of these leaf nodes is one of those instances, right? Those 8x8 instances. And one more take. Right, so what we're looking at here is a 5x5 grid of instances where each instance is that 8x8 set of ellipsoids. And it kind of looks like water, which looks quite nice, especially with that PBR. So maybe we'll use something like this in the game, or, you know, it's quite pleasing to the eyes, I think. So the tree would look something like this. It's not actually this. This is just a debug visualization of a tree. Where each leaf node in this would be an instance of that. It would just be this instance thing, and it has a link to the bottom level BVH and some transform data, so it translates it from local space into world space, so it can have stuff like rotation, scaling, and translation. Right, that's good. What else can I say? And rotation and translation. Right. So let's take a look into some of the code and data structures that we have made. So let's take a look into some of the data structures and code that we've made for this top level BVH stuff. Something like that. Or maybe I won't even say that or put that in there. I'll just cut it out because it's kind of pointless. But yeah, let's go into the actual data structures, because data structures are quite easy to yeah, then our BVH node ends up having like a BVH ref. Right, let's describe some of these things. All right, so this is our data that's shared between the CPU and GPU. So here is our BVH reference. So this is a way to reference to a whole BVH tree by pointing to the base node of the BVH. So this is actually only 16 bits, but because we're on the GPU, we've kind of got to make it 32 bits, but it means we can pack it into 16 bits when we're on the GPU. So how we get into 16 bits is that it actually can address 24 bits worth of nodes, but we align our BVH to this BVH alloc align. And if we just quickly take a look at that, that ends up being aligned to 256 nodes. So when in our custom BVH node allocator, we align every allocation to 256 nodes. And so we waste a bit of memory there, but it means we can basically shift it to the right by 8 and then just keep it in 16 bits. And then when we want to get the actual base node back out, we shift it to the left. And then we've, got some savings there if we store it a lot of the time. Now what's next? So the other sort of ref that we have, or reference, which again fits into 16 bits, is this BVH child nodes reference. So this is a relative index from that base node index of the BVH ref. So we use this in the traversal code, and it uses some similar tricks, right? It only points to the first set of 4 nodes, and that is aligned to 4 nodes all the time. So it means what we can do is we can address probably about 14 bits worth of nodes. Wait, 16 bits worth of nodes, yep. And then in the low bits, we store the count. So the number of nodes, the number of siblings, also the number of children that we're pointing to, basically. So those store in the low 2 bits there by taking the number 1, 2, 3, or 4, taking away 1 and packing it into the first 2 bits. And then we unpack it like so. That's sweet. Right. Next one. Right, so when we build the GPU, right, so when we build the BVH, we used to just have this sort of BVH build ellipsoid, and this is our leaf node, and we just create an array of these BVH ellipsoid, give it to the BVH API, and that will just run a bunch of compute shaders and build a tree on the GPU. But the way the instance one works is basically the same way. We have our center position, our half dims, and our world from local rotation as a quaternion. But instead of a material index, we have a BVH reference. So the only thing that's different between these two is this one's an ellipsoid and this one is actually an axis line bounding box, I think. I still got to settle on that. But yeah, that's for future me to solve a bit. All right, next one. Yep. Excuse me. Right, so this is that BVH node structure. I think in the previous devlog I had this at 16 bytes per node, which is really nice because I could pack 4 of them into a single 64 byte cache line. But I had sort of some precision issues and I wanted to just get it working and deal with the packing later, but leave the door open for it. So I just decided to very loosely pack it into 32 bytes of information. So there's 8 4-byte integers that we're just packing the XYZ component of the center position, half dimensions, and space from local rotation into 16 bits of into 16 bits of data. And what you'll notice is that at the end there is a switch. You know, the 16 bits used here, again, there's 16 unused bits. Okay, so still on again. Right, and as you'll notice that there is the 16 bits used in this word 7, right? And it switches on the node type, which is stored here in word 5. Again, the packing is very poor, but anyway. For a parent node, these 16 bits represent a BVH child node's reference, so we can basically just offset relative from that base node index of the BVH reference, right? Or the current tree that we're traversing, basically. But if we hit a leaf node and we're in a top level, we get a BVH reference, so we can swap out the whole BVH tree to traverse a bottom level BVH instead. But if we hit a bottom level leaf, we've actually hit an ellipsoid, so we need to have the material so we can do the whole PBR shading, right? So effectively, this BVH node can support those, you know, either a parent node or the top level leaf, which is an instance, right? Or a bottom level leaf, which is a ellipsoid. So another key thing to take away is that when we hit that top level leaf node, right, what we've hit, like we have that BVH reference here, but that transform information is all part of the bounding ellipsoid. So we're able to sort of translate into the local space just using this information alone. And another key thing to take away is that the top level BVH is in world space and the bottom level BVHs are in the local space of the object, right? Just in case that wasn't clear. Yeah, we do that packing code. What else is there to speak about? Do I want to talk about my API? It is a bit much. It is a bit much. Would people really be interested in that? There are links to the streams if people are interested, right? Sorry, it's internal, wasn't it? I did a custom node allocator. I did mention that, but I didn't really, you know, it's a bit much to talk about. There's whole streams on that, which I can link to. Yeah, I'm kind of okay with that. So shall we move on to the plan, back to that plan again? So that's probably about like a few minutes of information. Yeah, so now I should talk about what we've built, why we're pausing it, the game we're going to be making, a high level idea of the game we're going to be making, the plan for the future, and voila. Amazing. Has anyone got any questions about what we've just been talking about by the way? Feel free to ask questions. Yeah, let's get something visual up, because it's always nice to have visuals. Oh, I should talk about the papers that I found. I found this real neat paper. This one is pretty cool. Come on. Did I just link to NVIDIA research and then tell everyone that... Oh, you son of a... I found this paper. I think I did it from my phone. You know, like a right Gen Z. Yeah, this one. So they do the compression even more than me, and they've got a really interesting. They do 8 nodes instead of 4 nodes, and it means that when they, because we've got a current problem in our traversal code that I really want to solve. So like when you're traversing, right, you could have 4 nodes, which are 4 child ellipsoids or child ellipsoid nodes, which are near each other in memory. Sorry, near each other in space, and they're like in a single node, or they have a single parent node, obviously, right? When you have array, you want to make sure that you find the closest ellipsoid first, so you can be like, my closest distance is like here. This node, that distance is, or this node, I've hit this one, but the distance is further away. So all of those child nodes, I don't even bother having to traverse you because I've hit an opaque object here. So like, you know, there's no point even traversing down into there. That optimization we don't do yet. This paper solves it by doing 8 nodes. And there must be a way to do it with 4 nodes, but I've just not been able to think about it. But they solve it in here, and it's quite clever. So they use the Morton code ordering. So I guess imagine it in 2D. So here's in 2D. There's 4 different directions of ray. Your ray could be coming at. And in 2D, right? And the way they solve it is they will go... See, it's not the best way of solving it, but it does a good job most of the time and it's cheap. Basically, they would traverse the tree in a particular order. So I don't know what the order would be. But yeah, is it in octant? Yeah, octant order. Yeah, so they talk about how they treat it like a Morton code in a sense. Now these won't be necessarily aligned like this. This one could be over here. But they have them in like assign Morton codes to all of them. So that'd be 0, 0, that'd be 0, 1, that'd be 1, 0, 1, 1. Right? Imagine like grid celling it. And based on the direction of the arrow, it will like traverse, it'll pick an order. So there's like a truth table, there's like a, not truth table, like a, depending on what direction your ray is in, it will just iterate the children in that certain order, and most of the time it does a better job than the random order. So there's the distance order if you do it the more... If you do a lot of overhead, trying to figure out the distances, I guess, and sorting them. But if you don't sort them, you can do this octant order and kind of get an in-between result. Or a much better result than just random, which we do right now. NVIDIA ML based on caching for... No, I haven't read that. Have you got a link? Welcome, Machine Knob. How's it going? So this seems like a good evolution. And then they pack those the AABBs into such low resolution, and the sizing, like the position is fully... Yeah. The position is the parent node position is full resolution kinda floats. They're probably packed a bit, but then the child ones are kind of really packed. They're relative from the parent node, and the half sizes of the box, like the bounds, are really packed as well. And they say that packing the nodes down into such small space, like the memory, like loading less memory, is a much better benefit than getting a tighter fit, apparently, according to this paper from my quick reading of it. So I'm interested in looking this in the future. Yeah, I want to probably just talk about optimization and things. But like problems where we're at. Right, so as I mentioned earlier that, we can basically make instances. The performance isn't really the best, but it's fine because in where we're going to next is I just want to be able to make a basic level and we can deal with better rendering later. I just need a way to be able to create content first. So I quickly just want to show you a couple of papers that I'm inspired by. So next time I'll probably be doing something like this and the types of problems that we have to yet solve. There was that one. Put in my learning resources on the Discord. What else? There was the other one. What was it? Oh yeah, I wanted to put hblock in there so I can close it for future Henry. There we go. Yeah, the hblock was the faster build. Yeah, building one. I won't talk about that. Right. Okay, so the current problem with our BVH node structure has got a kind of bit of a wider node where we have 4 children, and I've tried to pack it down because I'm aware of, like, I want to pack things into cache lines, right, and reduce the amount of memory I'm reading back and how much cache is being used up by these BVH nodes. And I was looking around, and there's another paper that actually solves this, and it solves another problem that I'm also having as well. So this one's called Efficient Incoherent Ray Traversal on GPUs through Compressed Wide BVHs. And this one uses 8 wide nodes. Sorry, nodes with 8 children, basically. And it packs them into 128 bytes. So that's 2 cache lines for 8 children. So that gets the same sort of ratio as I was hoping. Actually, no, it doesn't. Yeah, it gets the ratio that I have right now, I guess. Wait a minute. Maths. Yeah, 464, yeah. Yep. Okay, let's do it one again. Can I cut what I just said? Screw it, let's cut what I said. Oh, let's just do it again. Right, so one of no. So with my current BVH design, I have 4 child nodes per BVH parent node. So I have this, I had this thing that I was designing for where I wanted to fit the child nodes all in a single cache line, so it's more efficient. And also, my current BVH is a 4 wide child BVH. So there's 4 children per parent node, and they all those siblings or children sit next to each other in memory. And I tried to fit them into a single cache line, but I've ended up having to double it into multiple cache lines, 2 cache lines, right? Wait a minute, is that right? Yeah, they're 32 bytes each. So I was right in terms of, Ah, damn it. Oh, you got the paper, sweet. Take a gander. We present a real-time neural radiance caching method for half-trace global elimination. System is designed by handling fully dynamic scenes. No assumptions about lighting, geometry or materials or data-driven approach. Caching algorithms such as localizing, interpolating, updating cache points, By pre-training a preset of, right, train readiness cache while rendering. Oh, the training it while rendering and employs self-train. I'm struggling to understand where the ML helps. Does it sort of help you traverse down the right paths, or does it help you skip paths? Yeah, I imagine it's traversing down the. Yeah, interesting. I'll save that for future Henry. I can edit, can't I? Such a troll. Such a troll. It's kind of learning paths and reducing whole computation. You just call position inside the cache ML model and returns a full color data. What? It's bananas. That's bananas. What? There must be some artifacts with that, right? Let's see another recording. So the current BVH node, as you saw, is this sort of like 4 wide children, right, per parent node. So all those 4 children initially fit into a single cache line, but then had precision problems, right? So that was 64 bytes, but now they actually end up fitting into 128 bytes for 4 nodes. And then I was going to worry about the packing in the future. I also have a problem of when I am traversing down the tree, how do I pick the closest node so I can find the closest ray-verse ellipsoid first, so I can basically get an opaque hit and avoid searching the back end of the tree. This paper answers both of those questions, and it does it. So it's called efficient incoherent ray traversal on GPUs through compressed wide BVHs. So I'd like to try and implement this one, or future Henry will, after we've done all this work, which we'll talk about in a bit. And it essentially packs, it does 8 wide nodes instead. So each node can have up to 8 children, and it packs those into 128 bytes. So effectively, the same ratio that we tried to get earlier, 4 into a single cache line, this gets 8 into 2 cache lines. So it should be what we're looking for basically in terms of that. Right, so let's quickly brush over the things that we want to talk about. Right, so the way it sort of solves that problem was saying it's got to pick a direction. So the way this paper solves the problem of when it's traversing down the tree, how do we pick that closest set of nodes to traverse down and hopefully hit the closest opaque ellipsoid so we can not traverse the ones behind. The most ideal way is you would take your distances you would test all of the children and take sort the distances and then traverse down in that order. But that requires keeping a cache of sorting a. Wait a minute. What did I say in that previous thing? Did I talk about? Yeah, I didn't talk about why I wanted to fit those children into caches. Let me go back. And the reason why I want to fit as many nodes into a single cache line is obviously so when I hit. And the reason why I want to fit all of the siblings or children into a single or a couple of cache lines is because when you're running that traversal code, I want to make sure that there's very little interruptions of, oh, I'm going to go and fetch some more memory. And you're really just spending time running maths operations and optimizing that. And then the other thing you need to fix is that these BVH trees, you want to make sure they use as little memory as possible. So that means that the caches are not getting filled up with very wide BVH nodes, or sorry, not wide, wrong word, very big BVH nodes, and therefore chucking other nodes out of the cache. So these are the two main benefits to squishing the data down into smaller places. Smaller places. Smaller pieces. Done. Future Henry's gonna have to edit that. What a poor guy. Back to this. So when you're traversing down the tree, you want to make sure that you take the closest path with the chance that you're going to hit the most or an opaque ellipsoid. So you would populate a variable and say like, hey, my closest opaque hit is like 10 meters in or whatever. So all those nodes which are like more than 10 meters further back than you, back than the ray, you can basically like not bother traversing down those because you've already hit something closer, and that's where you get some good gains. So one of the ways you could do it is you could basically take your nodes, your sibling nodes or the child nodes, test all of them and get your distances and sort the distances, and then you traverse them down in that order, right? You traverse the closest one, then the second closest one. But then as you're going up and down the tree, if you've got a very wide tree with tons of siblings in a single parent node, you've got to store that data in the traversal code, and that takes up registers, and it's very bad. So you could be like, well, why don't you use a binary tree? Because if you use a binary tree, you just test two nodes and you go down one and you store like a single bit, and then you can go down the other one when you come back up. But then you're using a binary tree, and the whole point of using a wider tree is that you've basically you're getting better utilization of the cache, right, as we just mentioned a second ago. So there's this Right, so there's this sort of technique they employ here. So there's distance order where sort of the more sort of yellow and orange is, the better it is, whereas the more blue it is, the worst it is per pixel. And so they've got this thing called distance order, which is that really expensive one we just mentioned, octant order, which we'll go over, and then random order, which is what mine is currently, and it's something I want to solve. So the octant order is effectively, you take those 8 nodes, so they're showing it in 2D here because it's easier to explain, but they use that Morton code earlier, which we saw in the previous devlog, and based on the ray direction, so they'll just be like, well, is it mostly pointing diagonally up, diagonally down, or right in those 4 different directions? And based on those, it will just essentially have a preset order of which of the nodes to go down. So if it's going diagonally up and right, it's most likely going to hit this one or this one, right? So it'll go down in that order. And then this one here, and then at last this one. So it'll go this one, then that one. Right, what else am I going to say? So obviously this isn't going to get you a good guess all of the time, but it's a very quick way of just being like, give me an order which is most likely going to be the best, given this ray direction. Yeah. So I'll leave a link to the paper if you guys are interested in reading this one anymore. So I'll leave a link to the paper if you guys are looking at interested. Blah, blah, blah. So I'll leave a link down in the description if you guys are looking at reading this paper some more. Right, but I gave them the title anyway. Links are kind of nice. Cool, so I've spoken about where I want to take the BVH next, what are the problems with my current version. That was cool. Future Henry can look at that. This is all good. I'm closing windows. We'll get to talk about the game now. So before we go into the little plan that we have of the next 4 to 8 months, we'll quickly discuss sort of a general idea of what this game is. I'm not going to go too much into the details because I want to reserve that for the future and also iterate on it more. So effectively I want to build like a top-down RPG that's kind of like turn-based, but it's going to have some kind of like real-time element to it. And there's going to be essentially this world that is simulated along with you. So if I move through the world, the rest of the world is also going to take their turn as well. And so there's going to be a lot of entities that are going to get simulated, and that is going to run every time you take a turn. So because it's going to be kind of like top down, right? There's not going to be like a first person camera or anything. It's kind of like just probably going to be a fixed camera. Maybe it'll come down a bit closer in some cases, but I think it's just going to stay fixed. We're going to build some form of editor which allows us to make these models. Make a model which is basically a bottom level BVH of ellipsoids, and then make a level which is creating instances of these models. So because we've made this whole custom rendering technology, it's better off if we just build it all into the game, and then it means that we can make tooling specifically designed for this game, and maybe even open it up to the community where they can make their own things as well and add it into the game. Hey Alex, how you doing? Good to see you. Yeah, I will reply to you, Alex. Sorry, I was really busy over the weekend. I've been doing family things. But yeah, it was a good chat. I'm enjoying it. I'll get back to you in the Discord, those for sure. But how are you doing, sir? Right. So as much as I've been having a lot of fun doing a bunch of rendering research and development, you know, I think I spent probably about 70, 80 or 90 streams, I forget, which is more than half of the time that I've done this whole project in doing research and development for rendering. And I've found something I want to settle on. So now that I've found that, it's in a good enough place just to start taking a break from it and doing the sort of game technology. So that's what we're going to be doing next. So the main goal for the game technology is to make an editor that can build levels and models. But I don't want to just rush and build all this stuff that I'm going to have to refactor later. Obviously, I want to have to refactor things later, but I want to try and avoid those big mega refactors because all the code is just trash. So I have a UI system, right? I have my own texture viewer built using it. So whenever I build these editors and things, I want to make sure that I take the time and at least make sure that I'm not repeating a very general, messy thing, and make sure that the code, I'll handle those places where I'm just going to generate a bunch of mess, so I'll have to clean them up later. But also put in API stubs for systems that I want to build out later, but just do a very simple API. So it means I can just change it later and know all of the places that reference this API. So a prime example of that is the asset system. I don't want to build a full asset system right now. What I would like to do is know all of the places that load and save assets. So I'll build I've just got an asset folder, right? I just have an asset folder where it's just got a bunch of font stuff and these environment maps now and this logo. What I would like to do is just have a system that loads the file from the asset directory, saves it out. Then in future we can add stuff like virtual file systems or an asset build system, but right now we don't need it. So I just want to, build out some of those sort of areas and make sure that I'm not gonna have to refactor a whole load. So let's get into the to-do list now. What about it? Meth, is that some programming thing? Like a library? Yeah, fine, I tell you about the game, I know. But that is as much as I'm giving away. For people who are supporting, they can read the design document. It's on I'm not keeping it complete secret. So for those who have access to the code, who support me, thank you so much. On Twitch or Ko-Fi, there is a game design doc in the docs folder. If you want to read through it, I did it while I was on holiday. I was like, I don't want to program, but I want to design a game, so I designed it. Yeah, so you can read it if you want. But we're going over the tech plan again. We went over the tech plan a second ago and refined it, but I want to record it for the devlog. Just a quick surface overview, then we'll get back into editing. I'll put this up on the GitLab tonight. Right. So to make sure I'm not overcomplicating things, initially I just put out some like, oh, I'd like to add an entity system, or I'd like to add OS threading and a job system. And then I've refined those down into kind of like little tasks, which would take so many streams, or maybe they're just little notes. So I could break things down into like a 1 stream or 3 streams basis. So because I stream 3 days a week, 3 streams is 1 week. So I can do all this, I can figure out how long these things are going to realistically take. And I've kind of over allocated a little bit in some places. And I've also going to multiply these numbers by 2 as a sort of worst case estimate. So best case would be no multiplication, and worst case would be multiplying by 2. Is it possible to share the link here to get 2 to 3 players for a playtest or game jam? No, there's no game right now, my friend. I'm happy that you're interested, but we don't really have much. We have rendering technology. We're currently building out the game tech, which allows us to then build the game. But that will come in a couple of years or so. Share your link. Oh, your link. You said my. Yeah, man. Send a link. That is cool. Fellow game dev, that is very, very cool. What sort of game are you making? Spill the beans. Ah. Nice. Multiplayer, free to play. Alright, your login register. See, this thing already is a bit of a... But you're making it very easy, I guess, for people to get in. That's cool. Maybe. Yeah, nice. Sorry, I don't really have the time, but I'm sure other people will. So, what am I looking at? Game plan? Yeah, what did I talk about the time thing, didn't I? Yeah. Right, so I'll just give you a quick high-level overview. You can pause the video and read everything. So it's all sorted in the order I would wish to approach it in. And also there's parts of it that are unfinished near the bottom. And there are some quite ambitious things near the bottom as well. So we need some kind of entity system, right? And I do want to do tons of entities. I want to simulate a whole world of things. I've estimated at around 73,000 entities that are going to be simulating, but it is a turn-based type of game. So when I take my turn, I could have, if the turn takes half a second to take, I technically have half a second to update the whole world. So maybe we don't need to do anything too optimized, and we could just keep things very easy to debug. But yeah, so I want to have 1 stream to plan that out. And maybe we do some data-oriented thing, right? Which you could say is like ECS-like, but probably try and not do that. We'll see. Next thing I want to do is threading support, basically in a job system. So, adding OS support is just gonna be like a stream, very easy. Windows, Linux, threading stuff. A job system, a simple dependency-based system, because I feel like if I were to have manually put the jobs in and put a barrier down, I think it'd be quite error-prone. So I want to have a simple dependency system, and I don't think it will get in the way of the... I don't think it'll take too much time to do the dispatching, hopefully. Another thing is we're doing... The reason why I want to add threading support right away is because I've already built a graphics system, and I'm going to be building an editor system and a game logic thing as well. The earlier I get the threading in, the less code changes there will be in the future, the less of a pain it will be. So yeah, that's the reason why I want to get that thing done this early. Another thing to keep aware of is when we have threading, there's going to be data races. I want to try and make some kind of like per resource, there'll be a tracking system. So when we have a read-only reference or a read-write reference to a single entity, there'll be a system that runs in debug, or maybe runs when I turn it on in debug builds, where it will aggressively check every single access and make sure that there's only one mutable reference that could ever happen based on the dependency system of the jobs. Now I got this idea from the wait a minute. I should there's a language for that. Yeah, best done at compile time. And that sucks. Too hand-holdy. Destiny, multi-threaded. We're crying out loud. So this kind of like multi-threaded job system thing is kind of inspired by this talk. It's not going to be like this. I don't think it's not going to be a direct copy in it, at least. But I was really inspired by the problems they've solved with their stack. I'm hoping to do a simple version, and yeah, wait a minute. Do it one more time. So this whole job system and resource tracking thing to prevent data races is heavily inspired by this multi-threading the entire Destiny engine. And this was done in 2015, so it's been a while. They probably have this similar system today, I imagine. And I've taken a look at it, and I really like the problems that it's solving. You know, if I have multiple jobs, I want to make sure they don't access the same entities and have safeguards in for that. But I don't think I'm going to do a carbon copy of their implementation. I'm very much going to be building it, thinking about my own problems, you know, as I'm building it, basically. So I'll leave a link for this down in the description if you're interested in watching the talk. PP, yeah, the CPPs. Maybe it is a bit of CPP. And also Rust as well, isn't it? No, we use C. So the next thing we need to do is jobify the engine or the game. We don't have much to actually jobify. There's not many systems, right? Just graphics. So we'll have a basic game logic thing which makes an entity or two, and then, you know, create some render data, give it to the render job, and that job will do the rendering. And that should hopefully be with the resource tracking stuff as well, which would be pretty sweet. So the next kind of thing that we need when we're building an editor is a way to decode and encode files. So we want a text-based version for the editor stuff, typically for version control and debuggability, but when we want to ship it, we need a binary version. I could be here all day with this. I need to just cut things and be quick. Asset system, I just want to put a placeholder in for it, so there's an API, so I can track those usages in the future when we build a proper asset system. It's just going to load from the asset folder, and voila. Prefabs and levels. We need a way to test some levels, and we need a way to Did I talk about how my game was me procedural generation? I didn't. Maybe I didn't, but I'll spill it here. We need to have a way of saving and loading prefabs and levels so we can make some testing levels for testing the game logic in small little areas, and also for modding purposes maybe in the future. But the game is going to be procedural generation later, so this will not be used for that, obviously. The next one will be a renderer feedback thing. So if we hover over an object in the editor, we need a way to know, like, hey, we've hovered over this object, so when I click it, we can select that object. So we're ray tracing against the whole scene, so we should be able to get this information from the renderer and feed that back into the editor and be able to select things and get other information as well. Gizmos is another one. So we need a translate tool, rotate tool, scale tool. We already have a debug draw 3D API. I don't think we have any shapes that are missing, so I think it should be quite smooth to create a bunch of all these 3 different tools. And there's probably going to be some feedback from the GPU when we hover over that debug shape. Neat. Oh yeah, there'd probably be a multi-threaded thing as well. Let me think about that. I've put in some time for, we're going to have to maintain the UI system. I hope there's not going to be much of it. So I've allocated 3 streams, so it's about a week. Because I want to make sure I don't just create a load of rubbish that I have to refactor. So 3 streams for that. Then I need a color picker widget. So I put 3 streams down for that, hopefully not. And then this is where we get to building the editors. So from here it's building actual editors. So we're going to pick the most simple editor first. So currently we just have one global material. So that's metalness, roughness, albedo, and emissive. This is a very simple one to do. We'll basically have a single ellipsoid in the scene, which we can scale and change the dimensions and rotate. And we basically just change some properties, see how they look, and then save it out to disk and load it in, name it, that sort of stuff. So I'm hoping that'll take 3 streams. We'll see how that goes. Now, you're demanding me that I've cheated by using Blender instead of making an editor. Well, no. Because you're using like triangles, right? I've got my own custom thing. So I need to... Well, I probably don't need to build something, but it would be nicer if I had my own thing. But yeah, it should be pretty cool. The biggest thing is as well, it's got to work for people who are going to make stuff in it, because I'm not going to make all the art. I've got to try and get someone else to do it, I think. So it's got to be good enough for that. Yeah. Make it yourself, all the art. I can do art, but someone else will do it better. And it's when I can get some parallel development in. I do programming, someone else does art. Voila. But that's when I figure out, that's when I've done game systems, I think. Or maybe I can get someone to do some concept art for a bit. Try something new. I try new stuff all the time. I gotta Yeah. Takes a lot of time to do art. I'm sure I'll find someone. The next one is the actual model, the model editor itself. So the model editor, you'll be able to make like a tile or make like an entity, like an organism, right? Like a player, basically. So I've allocated 13 streams for this. There's quite a lot of stuff here. This is basically a month worth of work, part-time, right? Month's worth of work. It's got all sorts of things, right? Saving and loading, undo redo system, adding, removing ellipsoids, setting a material, multi-select, rendering a selection outline, camera controls, aligning to a plane, transforming, but with multi-select, right? So translate, rotate, scale. So that's a lot of stuff. This is probably the most fiddly bit, where we end up, we have to do a bit of maths basically and get that right. But yeah, this will allow us to build a model and save it, load it, and have that being built on the GPU as a BVH. Yes, the game format will be saving the final ellipsoids, but realistically, when we could probably just serialize the BVH out, and then you don't have to build the bounding volume hierarchy when you boot up the game. So yeah, maybe you just save the final set of ellipsoids. No, just save out the BVH, but then, damn it. Yeah, we should probably save out. See, when someone starts making content, we'll need it to be BVHs. Let's save out BVHs. And then if this file changes, build them. But then you need an asset build system for that. We're not going to do one. But if I save out the BVHs, I want to change the format anyway. The editor stores a list of edits. So you can resolve that into a final list of edits and then build the BVH anyway. Yeah, let's just save out the BVH. It'll be way better, because then I won't have to build a BVH building system when we load in an asset. Ta-da! Concept art, mid-journey, depending on one's view this as cheating. Yeah, so yeah. I don't know if I could do mid-journey because of my custom rendering thing. Getting it to generate ellipsoid images might be a bit weird. Maybe I might be able to do it. But yeah, just getting someone to do some initial. I think what I meant by just some simple art within the game, concept art, not making it in Photoshop or whatever they do, Blender. But we're multi-selecting not possible shearing. Right, I don't think we're doing shear. We haven't got shearing support. But that's, thank you to know, Isaac. I'll keep that in the memory. Ooh, Marco Bruno, thank you so much for the raid, sir. Welcome, guys. How did the stream go? A nice name, by the way. We're currently going over the game technology to-do list that I've put out, or that I've made over the weekend. And this is what we've got working so far: PBR, BVH, ray traced, ellipsoids with instances, and we're taking a break from that and doing some game technology. Yeah, proof of concept art, maybe. Yeah, that's a better way of saying it. Yeah, that's what it probably would be. But yeah, if anyone has any questions about the project, it's all in a custom engine written in C from scratch. Any questions about anything you see or want to ask about, feel free to ask away. I'm from Brazil. Some of you are Brazilian. Some speak English and others don't. That is cool. Well, hello for those who speak English, and sorry for those who do not. Well, ray traced. Yeah, what's the problem with ray tracing? Ray tracing is the future, mate. Yeah, so I talked about that one. What's on the next to-do list? Your name sound Italian. Have you got Italian origins? Right. Right, so the next one is a prefabs / level editor, basically, because they're basically similar things. I've allocated 8 streams for this. We need to generate like a little grid of tiles, basically, and then be able to place down organisms on there and change their properties and basic rotation and stuff. And, you know, so hopefully 8 streams should be less complicated than the model one. Right, so the next one is all like model animation and things. I'll briefly touch over this, but I've still got to refine it, which we'll carry on with after we've done this devlog thing. So the final two are basically the model editor animation. So we add animation support to that model editor that we just went over. So it has like a whole bone system. You can make bone hierarchies and save and load them, picking which bones the ellipsoid gets affected by and the weighting of that, and having an animation system, if you will. I've still got to scope this one out a bit, so I'm doing this in a bit. And the other one is like this thing called like an organism editor. Basically, it's an RPG, so we want to have a way to, like, you know, swap out like head parts, hand parts, arm parts, torso parts, legs, and shoes. So we need a way to be able to create an organism template. Maybe there's not just going to be a humanoid shape. Maybe we have different shapes. And we need a way to be able to build these organisms and just sort of like see how, you know, if they dress like this, how does it look, basically. Right, so that's basically my whole recap. We're going to drill more into this in a second. I just want to record the outro for the devlog. I've put way too many markers down, so future me is going to have a problem with that. What was my past? Let's go to YouTube. What was the past one? Just double check it. 15. All right, where's the VOD channel? VOD channel says. Oh no, I did put. Right, I thought I missed one. That's good. Right, so 3.8. Construction recap. BVH custom allocator. Boy. 48. Right, this is good. So yeah, after we record this, we'll go over some more of the we'll refine this a bit more, the more advanced stuff, and try and break it down into something sensible. Oh, I didn't talk about the times. No, I said 4 to 8 months. That's all right. Hey, Tapir. Thank you so much for the raid, sir. How you doing? Welcome, raiders. We're currently working on the game tech plan. I've just recorded a devlog which goes over the top level BVH stuff we just completed. How did the stream go? And I'm just wrapping up the devlog with an outro. Then we're going to get back into the game tech plan for the next 4 to 8 months, which involves making an editor for building models and things, and other things like threading. But yeah, any questions, guys? Feel free to ask away. Yeah, it's all custom engine written in C and things, PBR. Good. Changed how I store user data, basically. Right. Cool. Awesome. Interesting. So what's your overall goal, like, with changing that user data? What was the problem with the previous one? So serialization to disk. I used to use Steam Cloud, but I want to reduce my third-party dependencies. Ah, good idea. Yep, that's a very good idea. Awesome. Yeah, that's one of the things we went over is a serialization system, and we're probably not going to make a system. We'll just make serializers and just manually write the serialization code, because yeah, I've made too many of these systems before now that are automated, and I'm not liking them. They're too automated, and debugging is hard, and doing edge case programming is difficult. But yeah, serialization, that's on the list somewhere. Right, just record this outro quick and we'll get back to the list. Right, so that does it for devlog 16. The days are day 140 to day 148 if you're interested in seeing the live recordings. These will include stuff such as making the custom BVH node allocator on the CPU, and also making the whole BVH API. So if you're interested in seeing that stuff, which I couldn't cover today, unfortunately, that is all on the VOD channel here. Also a Twitch channel where you can catch me live Tuesday, Thursday, Sunday, and there's a Discord if you want to come and hang out in the meantime. And if you're interested in getting source code access, if you support via Twitch or Ko-Fi, there's ways to get access to the GitLab source code. When you subscribe, you can go onto the Discord, and it has all the instructions there. Thank you so much, guys. See you in the next one. Cool. Done. Future Henry is going to have good fun putting that together. Yeah, the renderer itself is self-made. We built a BVH ray tracer, which is not the best right now. I'm not happy with the performance, but I got it to a place where I'm like, this will do. But we'll come back, and I found some more papers which I can implement and do those. So I should be able to have a world that's sort of top-down, ray traced, yeah, and made with ellipsoids and things. So it's all using compute shaders, because I want to try that limitation. 3D graphics APIs are really complicated, and I want to, this project, see what it's like just to write everything using compute shaders. It's been fun. There's definitely been some different ways of thinking about things. Like 2D rasterization has basically bin things into tiles and do tile-based rendering. 3D rendering has been, you could do tile-based binning, you could do BVH acceleration structures, but you basically ray trace. You could do an atomic max, right? Operations rasterizations thing. People do that. But yeah, you don't get triangles or anything like this, so it's different. But yeah, it's a bit of fun. The API is dead simple though, I can tell you that. Like, my GPU header is 330 lines, and it's a Vulkan backend. So I've just got some basic format stuff. I can create textures, upload, read back. I've even over-engineered it a bit and done different readback APIs. Sync code, some special operations to zero buffers and textures, and dispatch, compute shaders, and then profiling. So I get profile information back, texture viewer, and initialization, I guess. So, no, I'm not going to do mesh shaders because I'm not doing traditional rasterization, because the problem is you end up with pipeline states and render passes, frame buffers. So we don't do any of that. We just draw to textures. Yeah. So it's a bit of fun. Something different. I actually got the idea from someone at work who's doing it with his sort of like 3D voxel engine. So I thought, it's kind of a cool idea. I do like the idea of simplicity. But it is a trade-off. Definitely. Right, so after we've built this sort of model editor and prefab editor, we probably want to have a way to like move and animate models, right? So within the model editor, you'll be able to build some sort of bone hierarchy for a particular model, and save it. Yeah, so building the bone hierarchy, I've just said 6 streams. Saving and loading, a couple of streams. Waiting, you want to be able to automatically assign bones to the ellipsoids by basically picking a threshold of like, a threshold of how far the bone is from the ellipsoid, until it classes as being one that you assign it to, right? And you pick the closest ones. Weight painting, you're basically just saying, yeah, maybe it's painting. Each ellipsoid can have 4 bones it's attached to. How much of the bone is applied? Yeah. Yeah. How much weight does that bone have? And that could be, again, done by distance automatically, but it could be tweaked in the editor. Then, so I should probably split this out into like bone hierarchy creator, and then bone, and then this other one is like, this is when you have bone, it's just a bone I guess weighting, or like this is like attaching bone and ellipsoid attaching system, I guess. I don't know. Yeah. So basically, like, let's talk about that. organism thing, I want to have like a, because it's an RPG where I'm gonna be able to change places, right? Sorry, change pieces of an organism. So imagine if you have like a humanoid. I think we're going to build AABBs that represent different things you can change. So it'll be something like this. Each box is its own model that you make, right? And because we want to have a skeletal animation thing, so yeah, in the RPG they'll be able to select different items and things, right? And then they change on the thing. So because we want to have a skeletal animation thing to do animation, we want to make sure that we don't just hard code a bunch of skeletons or hard code one skeleton, you know. Maybe we want some helmet thing to have some bones to animate the actual ellipsoids. So each, we might provide a base skeleton, but each piece can define its own skeleton and it all gets linked up together. So there's going to be these connector pieces between the, so that you've got to put a bone that attaches to here. You got to put a bone that attaches to here between the pieces. And then each model can have whatever the hell it likes in here. It can do whatever bones it likes, but as long as it attaches each side. So the way that I'm thinking about doing it, yeah. Yeah, so when I say like an organism slot, this is what one of these is. And each, so I want to have a way where we can create non-humanoid humanoid objects as well, or have that possibility. So you'll be able to make, simply just line up some axis line bounding boxes like this, and where they align, you can choose where they touch. You can create the connections and put the, choose where these things go, right? And then when you make an organism, the game, like there'll be a skeleton that gets stitched together, and then whenever you make, and the beautiful thing is, whenever you make this sort of like customization piece that's made of ellipsoids, right? And you've got this custom bone thing. Maybe you got bones that stick out for some reason, so you can sort of like control how something works or whatever. You've skinned everything locally. Sorry, all the weights for the bones are done locally, so it just, yeah, it just makes sense. So we don't have to worry about having a skeleton that is pre-made and then somehow fits over the somehow you incorporate that pre-made skeleton into your model that you're making. So yeah. So that's pretty neat. Maybe we could define a base, because no, we won't define a base one. We'll just make it such that when you make, you can define some preset skeletons or hierarchies. Yeah, so this is the animation system. So animation system, so let's break this one down. You obviously need to be able to take a, so the thing is with the animation system is that does it work with this design? Like, you want to be able to take a take a skeleton and define its sort of position and rotation and scale, and I guess tween between two places. But if you're not going to be defining the whole skeleton up front, is that going to be a problem with the animation? Well, so this is a top-down game. It probably doesn't need anything too complicated, maybe. But saying if I'm playing like a run animation or whatever, or a move animation, maybe we could make each animation that plays has a key. So if this has special animation for running or whatever, or maybe like the thing is, like these legs, right? You have like knees. You have a bone here where, but then like maybe you want to make yeah, something to think about. Because if you end up moving your sort of like so if I'm just walking the player and I've built different leg pieces, in the animation system, you don't want to animate every single leg piece, right? Maybe what you could do is you've made a base skeleton. Yeah, maybe you'd have to inherit something, you know what I mean? So then you have the inheritance problem. But yeah, maybe there's a skeleton that you can get for this particular leg piece. So it already has the walk and the run type of like animating being done already to it. And if we need a bit of a custom, maybe there's just additional bones that go on top. That's another option. So we could provide a skeleton where no, because you want to put extra bones in for, or perhaps there's some bones that have to be defined and they're special bones, and those ones, yeah, I think that's the way we do it. So the head bone has to have a bone there. You have to have a bone here for the elbow. You have to have a bone there. Have to have a bone. Upper chest. Yeah, but and I'm not sure how much twisting you end up doing, but let's just say there's predefined sets of bones per organism piece. And this is what you use to do the general animation. Yeah, so where do I put that? Define key bone key bones used for animation. So one stream for that as well. Yeah, so maybe there's these key bones per organism piece where they're just there, so, and they could be moved anywhere, but we define a preset position. Can be moved around by the model. Not fixed, can be moved around by the model. That's interesting. Yeah, so if they have any sort of like extra bones, say if they've got like a decorative thing that they want to move around differently, they can put the bones on. So yeah, they could put the bones on and they will control how those things sort of move around a bit differently. So especially you can have this on the headpiece maybe. So say if you get those extra bones that go on top, the way those are animated might be procedural maybe? Like, if the thing is to move, like the arm, if the arm is to move or the head is to move, you could just take some vectors in and then procedurally animate the bone, those extra bones. But then like, say if I move this bone here and you might need, yeah, maybe there'll be a few different bones so you can get a nice bend. Or get a, or maybe if the character wants a special bend, they could define these ones that connect up. So if I move it here, the animation system moves that bone there. The rest of the bones could probably have some in between one or something. Yeah, it'd be like an interpolation between it or something like that. That's possible. Right, so I think we've got our idea now. So let's write it in. So we need, so each organism piece can have, will have key bones. Key bones such that a whole organism can have its own set of animations that will just work with any model. They'll just work with any model. They'll just work with any model. Any model created with that. Any set of custom models, I guess. Right, that's interesting. So we need a way to So with some kind of like animation system, what we're looking for this to be like. Hmm. Move keybones. Wait a minute. Move keybones. Yeah, that'll be fine, I think. All right, what is next? So the animation system. Essentially, you want to be able to define like where so there'll be like an idle pose, and idle goes into walking. And we'll have ways of interpolating between two animations. So you get a nice smooth blend, right? So we need a way. So when defining an animation, there's all sorts to build. There's a whole skinning thing to build as well. So I guess let's just talk about the editor side first. So you need to be able to create an animation, so we need the data format. Let's say that's one stream. The next one is create an animation. So I need a UI for that, basically. You create an animation. You probably don't have ways to delete it because it's just on the file system, maybe. Right. To create a new animation, you can just delete it from the file system, right? Unless there's links involved, maybe we won't. So after you've created an animation, you define. I guess there'll be like some kind of timeline. Do I want to do a whole timeline though? It seems quite. Well, it's not that bad. Doing a timeline. Yeah, so you probably need to make a timeline, and you put your bones will be at an initial space. So yeah, let's say create animation takes one stream as well. So it'll be like a timeline, and your bones will be at some initial place for that animation. And then you would move it to a certain spot. You have a keyframe, and you can probably just lerp between those two positions. And I guess that could be version 1.0, where I just get that working. So you need positioning of those key bones. You need to be able to select something. See, the animation system is probably outside. It's outside of. It's a whole nother editor. It's the animation editor. Screw it. That needs to be done after the organism editor, actually. Right. Yeah. So basically, you have a timeline. and you'll be able to put keyframes down. So there'll be a base frame where everything is. You can move it around. You have each of the key bones for right. One timeline for each. One timeline for each key bone. Procedural bones. I've not really talked about the other bones, but we should call them procedural bones maybe. Yeah, they're all procedural. Where have I done this? Bone. Ah, that's it. So all non-key bones are procedural. All non-key bones are procedural. So we could select, like, is it just a basic interpolation, or is it, you know, if it dangles select different behaviors for the procedural bones. Procedural means animate. Procedural means animated with code. Neat. Timeline. Yes, you have a timeline for each key bone in the whole organism, right? Each animation is for an organism. There we go. So timeline and keyframe, one timeline for each key bone. You need to be able to move, way to create the create keyframe. So add and remove keyframe. We'll probably just automatically tween between the two keyframes. There might be some other options in the future. I've got to think about it some more. But just basic tweening will be enough. So put the keyframe down. Then you need to have a way. So that's just the timeline. You need to be able to play it. Be able to play it back, pause it, play, pause, and also select, drag, seek. Seek with a mouse or something, right? Select, I don't know. Right, so given, so after that timeline, we'll add another one separately, which is basically transform. So you're moving the, I think we'll do 2 streams for that, because I think we might have to do some stuff with the, right, with the packing, maybe. Nah, 1 stream's alright for that one. Transform bones. you know, translate, etc. Screw it. Rotate. No. Right. Yeah, transform the bones, you move them around. Put them into a position. Yep. So you can build. Okay, so I guess let's spec this out and then we'll think about more of the outside of the creation of the actual animation. You know, how do you attach multiple, you know, do you just build a run animation and then a walk, that sort of thing? And is that automatically tweened or is there other level, you know? So timeline, how long we're going to take to do this? We need to build the UI. The actual UI for it, right? There needs to be something there. So let's just say that takes 3 days, 3 streams. So that's only 12 hours. Wait, is it? About 12 hours. To build a UI. Maybe we could do it in 2 streams actually, I reckon. Let's be optimistic. Add and remove keyframes. That could probably be done in one. We're going to over allocate, I guess, by just doing it separately. We also need undo and redo. I forgot about that one. Undo, redo. We probably already have a system in place already. Undo, redo, on stream. So transforming, alright. Play, pause, and seek. Let's put that all under one stream. So what else are we missing from some kind of timeline? So you can click. You want to be able to like drag it, or maybe change. Oh, there's like keyframe properties. Keyframe properties. So there's one more stream. You know, like edit the start and the so when you edit the positions of the keyframe, we could maybe do like a bit of dragging support, but equally another way of doing it is clicking on it, changing the value in the properties and getting it precise. That's another way of doing it. Yeah. We'll see how that goes. Yeah, I think that's, you know what, the UI might take 3 streams because I think I'll do it in 2 streams and then come back and do some more touch up. Right, transforming bones. We've probably already done a whole load of that, so we could probably just be like, that's. We could probably just say that's going to take 1 stream. Do we say you can move multiple bones? We probably won't. Just do singular. So all in all, for an animation editor, does it seem too small? Too little? Let's see. 1, 2. So all in all, I'm saying that's what? 7 streams? So that's 11 streams in all. So that's a month. Just under a month. That'll be right, wouldn't it? So just under a month worth of work on the side, an animation editor looks feasible. Yeah, we'll probably have like a lot of the systems in place, so that should be kind of smooth sailing. So I didn't really talk about that. So when you have an animation, and we'll probably have like special like walk animations. Sorry, we'll have like the game will be like, hey, you need to play that walk animation, and then an organism will need to implement the walk animation, right? And this animation, that animation, right? Um, yeah, yeah. I think that just makes the most sense. And then basically, we might have it predefined in code somewhere, like when you're going from a walk animation um to a run animation, and then blend it. Um, is there much point having an editor for this? It will take time. Where you could say like, hey, he's got this. You have this sort of like walk animation. I'm going to running, and then sort of blending between it. That seems like I could just do that in code, and then if we need more, I'll just program more in. I don't think there's gonna be a bottleneck where it needs to be an editor, where the higher level animation tree, if you will, needs to be an editor. That's just more work. This is going to be beneficial. So the only one left we've got to do is this organism editor. I have gone over this off stream. I did kind of go over it here when we talked about it here. Is there anything else that needs to be refined about it? So we've got the save and loading to disk, basically. Creating templates, just aligning some ABBs, and then defining some connecting bone positions, key bones, and then after you've made your template, you can pick a bunch of pieces. Oh yeah, in the animation editor, are you picking an organism? Yep. So you probably pre-pick an instance just so you can make it look nice and see how it works. Pick and choose different model pieces. Pick and choose different model pieces, slot together, and then you save those out basically. Yeah, that's all right. I did 3 streams for that. Okay. So all in all, this one is 9 streams. Okay, so if we add up the second half, so the first one was about 50 odd streams, wasn't it? So that's how many? 52, I think. So divide by 3 a week, divide by 4. So it's about 4 months worth of work in terms of working on it as a side project. That was before the animation stuff. So animation, we didn't add all these up, did we? 6, 8. Oh, what is this? Oh, that's just document. Okay, yeah, documentation. 9, 10. It can't just be 2 streams for that, can it? Bone and ellipsoid attaching system. So you got your hierarchy. I'm just doing weights. Yeah, I think so. So let's just say that's 10 streams. Okay, so if we add up 10, 9, 11, so that's 30 streams for the extended animation thing. 30 divided by 3 divided by 4, 2.5 months. That seems to make sense. So hopefully, all in all, there's about 4.5 months when it's at 7 months. That should be it. Game technology. So after that, we'll have enough stuff to sort of build and edit these sort of like models and things. And yeah, interesting. Then have the base game technology where we can start building out the game. We'll still probably have to work on the editors a bit more to refine workflow things and maybe add more features. But that'll be the minimal set of things. I wonder if there's ways that we could cut time down, though. That would be something that I need to look into as time progresses. So that will be 7 months of work. We don't have to build the animation stuff right away. That's something we can do later. Yeah. So we could... Hang on a minute. This has to be done first. Yeah, so maybe maybe we could save the animation stuff for another time and get back to doing some rendering or something and just ironing out some of those kinks with the performance and then come back to doing some animation or something, depending on how much I feel like changing away from this when I've done it. Yeah. Right, so I think I want to put a pin in it today here. I want to spend some time thinking about this overall plan in the future. If you have any comments or things you want to chat about, in the meantime, there's a Discord channel where you come and ask your questions there. But I need to find a way to trim off some time if possible, because that is quite a long time. What features could we possibly trim out until then? So a lot of these, maybe we can spend less time on the entity system and just not bother with the plan and just do the most basic one. Yeah, I'm hoping we go with the most basic plan. The rest of these, we probably cannot trim these down anymore. Then UI maintenance, I'm hoping we can just throw away. And we won't have to do much of that. Maybe it ends up being like just part of the time it takes to do the other tasks, hopefully. But it's there. Color picker widget. Maybe I could do that quicker than 3 streams. Material editor. That's probably can't trim out. This one's 13 whole streams, but that's me being very generous, I guess, with the times. So maybe we could skip the multi-select stuff. Or maybe it's something we could do. I don't know. Yeah, have a think about it. Maybe it's things we can trim out. But it'd be pretty sweet when it's done though, it'd be pretty cool. And then we can move on to doing rendering again, and then get, after that, actually make a game. And start putting a plan together towards making the content. That would be pretty sweet. Cool. So, raid and stuff. Let's find someone to raid. I'll next be on Tuesday. We're going to start this plan. Doing entities. Getting that in the game. Tuesday, Thursday we'll probably be doing more entity stuff. And then Sunday as well. Hopefully we'll have wrapped up by next week. Yeah, no worries. Thank you, Alex, for coming. I'll get back to you on the Discord hopefully soon. And I'll post this up on the Discord as well, if for those interested in reading over the plan. I need to see dev, you know what I mean? Bam 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 bam. So I was hoping to get all that stuff done before another child arrives, you know what I mean? So hopefully that's the case. This guy, assembly. Zorchenheimer. Right. Have a good start to your work week, everyone. I'll see you all in the future. Thank you all for coming. I'll see you all soon. Catch you later.